Good morning, students. Now, in this session, we are going to study the surface hardness method or rebound hammer test. So, in the previous session, we have discussed regarding the different types of testing systems, that is, non-destructive testing systems, destructive testing systems, and semi-destructive testing systems. In that, different types of testing systems, we have listed out the different types of non-destructive tests. Okay, out of that we are going to discuss regarding the rebound hammer test. So after listening to this session, the students can understand how actually the rebound hammer test will be conducted and what is the advantage of the by conducting the rebound hammer test, and they are seeing what is the range. That means for particular type of ribbon numbers or ribbon index, what is the type of concrete quality. So according to our syllabus, we are here, that is destructive, non-destructive and semi-destructive testing systems. In this, we are going to study the particular type of non-destructive tests. So non-destructive testing systems, we have discussed some of the, we have listed out some of the different testing system, testing methods, that is surface hardness test, ultrasonic, resonant, and these things already we have discussed. Now in this particular session, we are going to discuss regarding the surface hardness method. By conducting this method of test, we can find what is the hardness of the test and what is the on approximate strength of the concrete also we can find out, that is plus or minus 2 according to codal provisions. Plus or minus 2 will be achieving, or plus or minus some percentage will be, we are getting the compressive strength of that particular concrete element. Okay, so you can see here, this is a instrument, that is ribbon hammer. So this is just like hammer, this is a hammer which is hits to the concrete surface. Because of that, this we are calling as ribbon hammer test. If once it hits to the concrete surface, it coming back, that ribbons depend because of the concrete strength. So for that purpose, we are calling this as ribbon hammer test. This is the instrument. Here we can observe some of the graduated scale is here. For this we are calling as hammer, and this is a graph. Okay, now this the recently the digital ribbon hammer machines is also available. In that, directly no need to see the graphs and all, directly the digital value, that is strength of the concrete or compressed strength of the concrete, we are going to see. But this is some of the old method. So generally this is the ribbon hammer method, that is the graduated scale. As it moves, when the it hits and its ribbon hammer, the graduated scale will also move along with that. Okay, that we can see in the detailed procedure of the ribbon hammer test. This is the instrument. Just let us see the ribbon hammer test. So by conducting the ribbon hammer test, what are the things we can achieve? Just we can go through this. It provides a rapid indication of the compressive strength of concrete. One of the main purpose of conducting this test is approximately we can find out the compressive strength of the concrete. Next, the ribbon of the elastic mass depends on the hardness of the surface against which its mass strength. Okay, based on the hardness of the surface and based on the strength, that gives that hardness is because of the compressive strength of that concrete, it rebounds. Based on that, we are going to find what is the rebound value. The rebound is taken to be empirically related to the compressive strength of the concrete. So indirectly we are finding out what is the compressive strength of that concrete. The ribbon value is read from the graduated scale and is designated as the ribbon number and ribbon index. As I discussed, this is the graduated scale. The ribbon number is measured from this graduated scale so that we can find approximately what is the strength. This depends on the surface hardness of the concrete element. Next, the compressive strength can be read directly from the graph provided on the body of the hammer. This is the graph which gives from this the by seeing this graduated scale value, we can see what is the approximate strength of the concrete. As I said, nowadays the digital display will be there instead of this graph. So the ribbon number numbers or ribbon number index will be affected by That means these are the some of the factors which affects the ribbon hammer number, that is mixed characteristics, angle of inclination of the direction of hammer, member characteristic test. So mixed characteristics, that depends on the what are the mix they were used while constructing. Next, angle of inclination, that means this should be perpendicular to this element. For example, this is a concrete structure, this is a rubber hammer machine, so this should be exactly perpendicular. If the inclination is there, it shows the less ribbon number numbers. So the ribbon number numbers will be depends on the angle of inclination of the direction of hammer. Next, member characteristic stress. After that, what is the type of member we are conducting the test? So these are the some of the three basics factors which affects the ribbon number test. So just let us see the longitudinal section of the ribbon number. Earlier I showed the ribbon number machine outside. So here this is the concrete surface which we have to conduct the test on this. Next, you come from this side, place this is the total body and this is the impact spring. There is a spring is attached here, rider on guide rod. So this is the rider. So window and scale. There is a window here. This is a graduated scale will be there. This is attached to this impact spring. Okay, or hammer. So this will move along with this. Next, this is the hammer guide release clutch. Next, compression spring, locking button, housing, and hammer mass. This is the main mass. So this mass, this graduated scale is attached to this hammer mass. When it is moves towards front, it will also move. When it ribbon from once again from here to here, the graduated scale from 0 to 8 moves. Based on that, we are going to find out. So here this is the procedure is very simple. This is the clutch is there. First we have to let us see here from 1 by 1. Instrument is ready for test. As I said, this is the longitudinal section. This is the spring, this is the spring, this is the spring, and this is the spring. You can observe here the body is pulled from outside. Here the hammer is ready to apply the load to the, so you just go through this. The method of using of hammer is explained in the figure. With the hammer pushed hard against the concrete, the body is allowed to move away from the concrete until the latch connects the hammer mass to a plunger. So the body is pushed towards outside, so as it connects the latch. Okay, this is the first procedure of the mechanism of the ribbon hammer. Next, the plunger is then held perpendicular to the concrete surface. If once it is pulled, the ribbon hammer machine is put perpendicular to the concrete surface where we have to conduct the test. This movement extends the spring holding the mass to the body. When the maximum extension of the spring is reached, the latch releases and the mass is pulled toward the surface by spring C. If once it reaches its maximum, so what happens? The latch will automatically release. So the body will come towards the mass of the structure or to the structural element. Next, during the burn, the slide indicator, the mass hits the shoulder and plunger rods and removed because of rod is pushed hard against the concrete. If once it releases, the latches is released, it's come and hits to the surface of the concrete. That ribbon which gives the ribbon number. See here the body mass which earlier at this stage, after it touches it move towards, then it comes forward, at last it comes to here. So during ribbon, the slide indicator travels with the hammer mass and stop at the maximum distance. The mass reaches after ribboning. A button on the side of the body is pushed to lock a plunger into retractor position and ribbon number is read from the scale of the body. So the last step is, if once it reaches its maximum, it ribbons from the surface of the structure. So along with this, as the graduated scale is attached to this, the ribbon number or ribbon index will be noted here. From that, we can see what is the compressive strength of the concrete. So some of the main advantages of the ribbon hammer is we can check the uniformity of the concrete. So for particular element, we can measure at the different places. Okay, for example, if we are conducting a test for a column, we can conduct the test on different position of that column so that you can check what is the uniformity of that concrete element. Next, comparing the given concrete with the specified requirement. So by conducting this required number test, we are not doing any surrounding disturbance for a concrete element. Just we can see what is the actual strength, existing strength of the element. From that, what is the actual requirement of the strength, whether we have to increase the strength of the concrete or we have to go for any retrofitting or different techniques. Next, approximate estimation of strength by using laboratory calibrated graph, abrasion resistance classification. So this is the graphs you can observe here, the ribbon hammer. From this we can find what is the actual strength. That means approximate strength there will be here. So this is the, here you can observe this is the ribbon numbers, and from here you will take, you are getting the actual strength of the concrete. So this is the interpretation of the results. If the ribbon number is greater than 40, very good, or hard layer, this is with respect to the surface hardness. Okay, this is the ribbon number. Based on this number, we are finding out what is the quality of the concrete. If it is 30 to 40, good, and as it is less than 20, the concrete is poor, and 0, it is delaminated. So these are some of the photographs which conducting the NDT test in the site after the building has failed. So identification of member. So like this is the actual field conditions. So the ribbon number test is conducting for this column. This is ongoing structures. Just we are finding out what is the actual strength of the concrete after the casting of the column. So like this the markages can be do. So for at each and every grid we can find whether any there will be different strength is there or not. Okay, so with this NDT test, in the next session we are going to see how actually the ultrasonic pulse velocity test will be conducted. So anyhow, this ribbon number test is also a very important test. So we can find the strength of the concrete approximately in the site condition without disturbing the surrounding concrete. Okay, thank you.